In this video, we're going to talk about adding integers. So first, we'll look at adding integers using counter chips. Counter chips are manipulative, where one side is green or yellow, indicating positive, and the other side is either red, indicating negative. So let's say we had the problem 3 plus 4. Well, 3 is a positive number, so we would represent it with 3 positive chips. 4 is also positive, so we would have 4 positive chips. To find our sum, adding 3 plus 4, we would count all of our chips. 1, 2, 3, 4, 5, 6, 7. So in total, we would have 7 counter chips. So 3 plus 4 equals 7. Another way we could model this is using the number line. When we have a positive number, positive numbers head towards the right from 0. So we would go 3 positive steps, or 3 steps to the right, and an additional 4 steps to the right. We're in the positive direction. Again, showing that 3 plus 4 equals 7. Now, what if we had 4 plus 3 instead? The commutative property says that we can change the order of our addends and it doesn't change the sum. So if we change our order, we would get the same answer. 4 plus 3. Again, we have 4 positive counter chips and 3 positive for a total of 7 positive chips. Let's look at another example. What if we have 2 negative numbers? How will this be different? So we have a -2 and a -5. Well, how would we represent -2? In this case, we would need 2 negative chips. And for our -5, we would need 5 negative chips as well. Well, how many negative chips do we have in total? If we count them, we have -7. So we have 7 counter chips, but they're all negative, for a total of -7. Now, what if we wanted to see this using the number line? So if we're heading in the negative direction is to the left. So our first step would be to take 2 steps in the left, or in the negative direction. And we also need to take 5 steps in the negative direction. And sometimes you'll see these with like little jumps or little skips. Again, we would have a total of -7. Again, the commutative property applies. We can change the order of our addends. So if we had -5 and -2, we would still get that same answer of -7. But what if the addends are not the same? So our first example, we saw 2 positives. Our second example, we saw 2 negatives. What if we have one of each? First, let's talk about a 0 pair. So a 0 pair is a pair of numbers whose sum is 0. So if I had a negative and a positive counter, they would cancel each other out and equal 0. So for instance, -3 and +3, they would equal 0. To show -3, I would have 3 negative counters. And to show +3, I would have 3 positive counters. Well, they would cancel each other out, because a positive and a negative equals 0. Well, this positive and negative would be 0, and this positive and negative would be 0. So our total sum here would be 0. On a number line, if we were to show this problem, what direction would I have to go for -3? Well, if it's negative, I would have to head towards the left. And then from there, I have to take 3 steps in the positive direction, or 3 steps from the right. So where I ended up, I'm now going to take 3 steps in the right, or towards the right, which again would get me back to 0 where I started. So let's look at -3 plus +4. First, my -3, I would represent with 3 negative counters. And then my +4, I need 4 positive counters. Do I have any 0 pairs? Well, these would cancel each other out. These would cancel each other out, or like balance each other out. And these would cancel each other out. So in this case, I would have one positive counter left over. So my sum would be positive 1. On a number line, I would first represent -3 starting from 0. I would take 3 steps or move 3 units to the left in the negative direction. Then from where I ended, I have to take 4 steps in the positive direction. So 3 of those steps would get me back to 0. I have to take a total of 4 steps. My result, I would end up at positive 1. Let's take a look at another example. What about 2 plus -5? How do I represent 2? Well, it's positive, so I have my 2 positive counters and 5 negative counters. And then think, do I have any 0 pairs? Is anything canceling itself out? So these would cancel each other out. These ones would 0 pair and cancel each other out. What do I have left over? I have 3 counters left over, and all 3 are negative. So my sum would be -3. If I show this with a number line, I'm first going 2 steps in the positive direction, which is to the right. Then from where I ended up, I have to take 5 steps in the negative direction, or 5 steps to the left. So 1, 2 steps get me back to 0, 3, 4, 5 steps in total. My result, I would end up at -3. You now go ahead and use this video to try some problems on your own. Good luck.